There we go. Unit 11, Day 3, Inverse Trig Functions. And today we learn why I keep hesitating when people say that sine and cosecant are inverses. Like, well, in one sense they're inverses, but with trig functions, inverse kind of means something else. So we want to say sine and cosecant are reciprocals, not inverses, because we're going to talk about inverses today. Well, let's back up a second and look at something that I think we're a little bit more familiar with. If x squared equals 9, so this is not trig at all, but this is very much related to inverses. If x squared equals 9, then what does x equal? Everyone's hesitant. Okay, 3, yes, but also negative 3. So remember, we got to be careful. X could be plus or minus 3. Let's say that's problem number 1. Problem number 2. What's the square root of 9? You're probably thinking, is this a trick question? I mean, you know what the square root of 9 is? Well, it's not plus or minus 3. It's just 3. Okay, if it's an equation, then it's plus or minus. If you put the square roots on to solve an equation, it's plus or minus. But if the square root is just sitting there, then it's just a positive one. Because the square root function has a restricted range. Meaning the output is restricted. Like, it could be plus or minus 3, I get what you're saying, but we've all decided, I wasn't in on the original decision, but mathematicians long ago decided that the square root of 9 was going to be positive 3, and only positive 3. Even though, if I square negative 3, I get a positive 9. So it's just like, by definition, we said, you know what, we only want one answer, so we're going to pick the positive one. Well, that's going to happen today with trig functions. So let's first talk unit circle values, and then we'll talk about picture problems. So let's say the sine of x equals 1/2. Sine of x equals 1/2. All right, well, you guys know the unit circle well enough, I think. What angles have a sine of 1/2? What's that? The middle one. What's the middle one? Well, see, it's positive, so I know it would be in the first quadrant and the second quadrant. 1/2 is the over 6 stuff. So pi over 6 and 5 pi over 6. But there's also others. I mean, those are the only two places, but there are other ways to get there. Right? Like, I could go backwards, negative 7 pi over 6. Or negative 11 pi over 6. ... because there's an infinite number of places whose sine is 1/2. But if we do inverse sine of 1/2, that's kind of the same question. That means find an angle whose sine is 1/2. Go backwards, think backwards. But I only want one answer. Which one of these answers do you think it is? Which one would seem to make the most sense to you if we only got to pick one of those to be our answer? Pi over 6. Kind of like the square root of 9. It's sort of plus or minus 3, but if I said you could only pick one, everybody would take the positive one. Same thing here. How many places have a sine of 1/2? A lot. But if you're only allowed to pick one, you're going to go with the first quadrant answer. You're going to go with pi over 6. How about the inverse sine of negative 1/2? Picture. So what angle has a sine of negative 1/2? Okay, so I heard negative pi over 6. It's actually the right answer. Very nice. What people are tempted to say, though, is 11 pi over 6. But that's not the same thing. They're coterminal. It lands at the same place, but it's not 11 pi over 6. Because you always pick kind of the simplest answer there is. The shortest, easiest, simplest answer there is. So inverse sine has a restricted range of, so here's the only place we can get our answers from, negative pi over 2 to pi over 2. Sometimes a picture is helpful. Let's see, sine is positive on the up and negative on the down. And so we're only allowed to pick from quadrant 1 or quadrant 4. And if you pick from quadrant 4, that's fine, but you have to use the negative angle, not the all the way around angle. So the big thing today is knowing what these restrictions are, so you know where, well, you got to know the unit circle. But once you know the unit circle, you have to know, like, what quadrant am I allowed to pull from for my answer. So we're going to talk about sine, cosine, and tangent, and then we'll kind of put them all together and see if we can hopefully make sense of it without trying to memorize everything. All right, let's do cosine. If cosine of x equals 1/2, cosine of x equals 1/2. Where might that happen? What angle has a cosine of 1/2? What's that? The over 3 one. That's a good answer. The over 3 one. So cosine is positive in the first quadrant, so pi over 3 would definitely be an answer. It's positive in the fourth quadrant, so that'd be 5 pi over 3. Or negative pi over 3. Or negative 5 pi over 3. Or an infinite number of other answers would have a cosine of 1/2. But if we tweak that problem a little bit and said, you know what, let's ask it this way, inverse cosine of 1/2, so that I'm only allowed to have one answer, which answer do you think it would be? Pi over 3. It's always the simplest, easiest answer. So pi over 3. What about the inverse cosine of negative 1/2? Maybe a picture. So cosine is negative on the left. So that would be there and there. Again, two options, or really more than two options. So which one of those answers do you think it is? He's on awake yet this morning. Isaiah, help me out. What angle is that right there? It has a cosine of negative 1/2.
What angle is it?
Yeah.
60 degrees?
It's more than 90, so it's definitely not 60, and I want it in radians.
I have no clue.
Well, anything 1/2 is always over 3, so you know it's going to be over 3. So I need to be over 3 in the second quadrant. It's over 3 in the third or the second quadrant, so that would be 2 pi over 3. Also, if you know the unit circle, this lesson is easy. If you don't know the unit circle, you're going to be stuck on this one as well. So that some of you, that's going to apply. And not just because of the values, but because of the positives and negatives. So, cosine has a restricted range. Again, let's think about where it's positive. Cosine goes with x, so it's positive on the right, it's negative on the left. And so I need to include both positives and negatives. So cosine I'll pull from the first or second quadrant. So cosine's always going to, the answer to an inverse cosine is always going to be between 0 and pi. In fact, let's try another one of those. Let's do the inverse cosine of negative root 2 over 2. So I want to find an angle whose cosine is negative, whose negative root 2 over 2. Well, if it's negative, I know it's in the second or third quadrant, but I'm only allowed to look in the first or second quadrant, so it's got to be that one in the second quadrant. So what angle has a cosine of negative root 2 over 2 in the second quadrant? 3 pi over 4. Right? Inverse cosine of 0. I need to figure out what angle has a cosine of 0. Cosine's the left and right, so left and right 0. It's got to be in between 0 and pi. So 90 degrees is one answer, but in radians that would be, so pi over 2. Yeah, you're thinking the right spot. It's that right there, which is 90 degrees, but usually we're in radians, so pi over 2. So you have to know two things today. You have to know the unit circle, and then you also have to know the restriction so you know which answer to give. All right, let's do tangent. If tangent of x equals 1, tangent of x equals 1, where does that happen? This is an equation, so I can have multiple answers. What values of, what angles have a tangent of 1? It is the middle one. That's a good way to think of it. That's a great way to think of it. What's the middle one in terms of radians? Pi over 4. What other quadrant has a positive tangent? What other quadrant are we looking at? The third. I'm not sure what that is over there, but yes, the third. So what's the angle in the third quadrant? It's got to be over 4. Well, you could get there a negative way, but if I went there a positive way, it's a little bit past pi, so 5 pi over 4. Now, it's not wrong to say negative, because negative 3 pi over 4 would land you there as well. So again, there's an infinite number of answers to where is the tangent equal to 1. But there's only one answer to what's the inverse tangent of 1. Again, it's the difference between saying x squared equals 9 and the square root of 9. One of them has two answers, one of them only has one answer. So I've got all these choices to pick from. Which one do you think is the right answer for inverse tangent of 1? Pi over 4. If it's in the first quadrant, use the first quadrant. It's when it's outside the first quadrant that things get a little bit tricky. Inverse tangent of negative square root of 3. Inverse tangent. Negative is in the second and fourth. if you remember the tangent shortcut, 3 goes with 3 and 2 3s make 6. So I know this is an over 3 angle in the second and fourth quadrant. So it's either 2 pi over 3 or negative pi over 3. This one's tricky because they had to just decide, well, which ones, they're both, it's not the first quadrant. Do you want to use the second or do you want to use the fourth? Any guesses on which one they picked? So there's two rationales. You could say, well, let's use the positive one, or you could say, let's use the closer one. And that was the debate, but they went with the closer one. So it's not the 2 pi over 3, it's negative pi over 3. So tangent's the trickiest because it's either the second or the fourth, and there's not a really good, clear reason. Like all the other ones, you just pick the closest one, pick the one that makes the most sense. But here, you could argue that either one of those makes the most sense. Go with the closest one. Which means that inverse tangent has a restricted range. Let's see, we had an answer in the first quadrant and we had an answer in the fourth quadrant. So from negative pi over 2 to pi over 2. This time with parentheses. Rather than brackets. The reason is, do you remember what the tangent of pi over 2 is? Sine over cosine, 1 over 0. It's undefined. So this is a minor point, not one that we really have to deal with, but tangent's restricted range doesn't include the endpoints because it's undefined there. The others are 0s and 1s, so they're okay. But that undefined business makes us have a parentheses there. All right, to me, here's one picture that captures all of them. So some of them are restricted to negative pi over 2 to pi over 2. That would be negative pi over 2 to pi over 2. So that was inverse sine and inverse tangent. And from 0 to pi is inverse cosine. And then there's still 3 more trig functions. Right? Those are just the main 3. It turns out the others basically go with their partner. So cosecant and secant usually dance together. So they're in the same spot. Sine and cosecant usually share some properties, so they're in the same spot. And then that lastly leaves cotangent. This one's a little bit weird. Cotangent does not go with tangent. It's because the asymptote stuff, it goes with cosine. So in my mind, especially for an open mode test, like that's what you need to look at. Because that's got everything you need right there in one spot. So if it's an inverse secant problem, you know where to look. If it's inverse tangent, you know where to look. They're not fumbling all around all over the place. You got one picture that you can look at to find everything. Let's do a couple of examples right there next to that picture. So here's what the problems are going to look like. They're going to be very, very straightforward. You have to know the unit circle, but the problems are straightforward. Inverse cosecant of negative 2. Well, nobody messes with cosecant. What would you rather deal with? Who's the partner of cosecant? Sine. So let's change this to inverse sine. But how are sine and cosecant related to each other? Yeah, you can do this. Don't say inverse, they're reciprocals. So that means I want the inverse sine of negative 1/2. So I draw a picture. If sine is negative, it's going to be down, but inverse sine has to come from first or fourth. So the down angle would be in the fourth quadrant. Over 2, or excuse me, 1/2 would be something over 6. And so that angle is, you tell me, what angle are we looking at here? Which angle is that? Shallow angle, fourth quadrant. What is it? Okay, that's what I was baiting you into saying. Good. So, yeah, if you're watching the video, you didn't hear that. She said 11 pi over 6 first, and then she quickly corrected to negative pi over 6. They do land at the same spot, and that's the tricky part. It's like, well, that is 11 pi over 6. That's true. But we're only allowed to answer between negative pi over 2 and pi over 2. So this one is frequently missed because people will put 11 pi over 6. It's like, it's so close. You knew the unit circle. You maybe even knew the restrictions. You just got there the wrong way. So get there the quickest way possible. Let's do another one while we're looking at the picture here, and then I got to turn the page, and we'll just have to see if we remember the picture. Inverse cotangent of negative square root of 3. Inverse cotangent. So I already know I've got to look between 0 and pi. I don't really think about cotangent values very much. So I'm going to switch this to tangent, but I'll have to flip it over. And I don't really like that because it's a square root in the bottom. This is about as bad as it can get, by the way, because we don't deal with cotangents, and then we got to fix it. And again, the tangent trick is that 2 3s make a 6, so I know this answer is over 6. So it's definitely over 6 because 2 3s make a 6. So it's the shallow one. Is it going to be in the first quadrant or the second quadrant? Why the second quadrant? Because it's negative. Good. So it's either in quadrant 2 or 4, but we're not allowed to look in quadrant 4. We're only allowed to look in 1 and 2. So over 6 in the second quadrant. What angle is that? 5 pi over 6. Good, because you're almost to pi, so you're at 5 over 6. So I'm thinking now I probably should have started with some unit circle warm-up problems to get us back in our brain back thinking that way. Let's do 2 more, and then we'll do a different kind of problem. The secant of the inverse tangent of square root of 3. Well, there's sort of 2 problems at one here. Secant of the inverse tangent of the square root of 3. Well, just like any math problem, you start from the inside and work your way out. So let's do inverse tangent of square root of 3, and then we'll worry about the secant thing. So inverse tangent, I'm immediately thinking that's got to come from first or fourth, because that's what I'm restricted to look at. Let's see. The tangent trick is that if there's 1 3, then the answer is 3. Something over 3. And it's positive, so it's in the first quadrant. Or the third quadrant, but we're not allowed to look in the third quadrant. So over 3 in the first quadrant is pi over 3. So the inverse tangent of square root of 3 is pi over 3. And then the secant of pi over 3. Secant. I don't want to mess with secant. I'd rather do cosine. Let's do cosine of pi over 3, but flip it over. So cosine of pi over 3 is, I've got a picture of pi over 3 right there. That might help. Cosine is the x-coordinate. That would be the short side. Short side's always 1/2. But secant means flip it over. So the answer would be 2. Correct. You don't flip the angle. You never flip the angle. I can say that. You'll never flip the angle. So you'll never have 3 over pi or 6 over pi or anything like that. You would only flip the value. That's a good question because we'll flip a value right here. Oops. Cotangent of the inverse cosecant of negative 2 root 3 over 3. Again, I'm throwing the absolute worst ones at you today. Cosecant. I don't want to mess with cosecant. Who's cosecant reciprocal partners with? Sine. So instead, let's do inverse sine. I have to flip it over, but that's a small price to pay to get to deal with sine rather than cosecant. Well, I say it's a small price to pay. So I flip this. I change it to sine, which is a flip. So I flip the answer. And then I need to fix that because that does not look like a unit circle value right now. But if I fix it, let's see, negative 3 root 3 over 2 times 3. Threes cancel. Inverse sine of negative root 3 over 2. Okay, that looks much better. That I can deal with. Still got 2 problems to do, but that looks a lot nicer. Okay, inverse sine's got to come from 1 and 4. It's negative, so it's got to come from the down quadrants. Sine is the y, root 3 over 2 is the long side. So I need it to be, steeper than it is long, and that means it's over 3. Is it negative pi over 3 or is it 5 pi over 3? Negative pi over 3. Although I guess the good news is, well, I don't even want to say that. Yes, it's negative pi over 3. And then the cotangent of negative pi over 3, cotangent, I don't want to do cotangent. I want to do tangent and then flip the tangent of negative pi over 3. Well, the tangent trick is if there's 1, 3, the answer is the one with 3 in it. So tangent of that would be square root of 3, but it's in the 4th quadrant, so it's negative. And then I need to flip that. Problem's forever long. So negative 1 over root 3, and then fix it. Negative root 3 over 3. Okay, we'll do the picture problems tomorrow because we need to get practice on that, and because you guys need to refresh your unit circle stuff. So I'll give you worksheet 5 in just a minute. It's going to be, today's problems are 1 through 24. 1 through 24 for today's problems. 25 through, so tomorrow's Wednesday. We'll do 25 through 45. Whoops. Yeah, that's fine. All right, so today's is 1 through 24. That's the main thing you need to know.